Recently, I've been talking to you guys a lot, and I gotta admit, me talking is probably not the most entertaining thing in the world by any stretch of the imagination. So today, I wanted to change it up a bit. So it's just gonna be me doing problems as fast as I can. I'm not gonna be explaining that much. We'll see what we can do. And today's topic, I think, is gonna be a bit more applicable to more of you guys because it is just general problem solving in coding. Hello everybody, I'm Kar, and today we are gonna be taking the Hackerrank skill test problem solving skills. I have no idea how this thing works, so why don't we just try it and see what happens? Let us see how fast we can finish it. Apparently it's 1.5 hours, but we shall see it. I don't have 1.5 hours now, god dang it. I'm really trying to record this at 9 p.m. and I do not want to be recording until 10:30. Dude, it's so bad. It's literally not even the school year yet, and I'm already starting to get busy, god dang it. But we are here now, we are recording, let us do something fun. And apparently, fun for me is doing Hackerrank. Dude, I'm such a nerd, god dang it. Alright, let's just start it off, shall we? Alright, we are ready. Let us do this thing. Alright, in the computer security course, dude, how ironic, dude. I'm literally taking a computer security course now. You just learned about password decryption. Okay, whatever. Let's just skip this up. Given string s, let si represent using, okay, initially, okay. If si is lowercase and the next one's, okay, that is silly. Come on, man. If si is a number, replace it with 0, replace the original. Stop if I is more than or equal to the string length. Otherwise, go to step 2. Okay, so let's just try it, I suppose. So basically, you go h is lowercase and next to uppercase, so you swap it and you put a star, okay. And then you move to I plus 2. Does that mean you move to the star? Oh, but the star doesn't matter, okay. So you move past the star, and now you're on C. And now this is a lowercase, but it doesn't matter. 3 is a number, replace it with 0. Okay, so this becomes a 0. And then that becomes a 3. Oh, and then you just, okay. And then stop once you get to the length. Wait, I'm not exactly sure how this works. Okay, let's look at the examples. Okay, so, for example, this 5 would be reached, okay. Yeah, seems legit. Okay, I get it. So let us figure out how to decrypt this boy. So essentially if you see a 0, then how do we know if, okay, so we obviously go from the back to the front. And then if we see a star, that means that it's probably the 2 before it are, you swap it, and then, what do you do after you swap it? Oh, you just swap them. So you go backward, you see a star, if there's lowercase, uppercase, then you swap them. Is there any way to get that? Wait, so what is the original string? Could the original string have a star in it? Input format, okay. Why don't we look at some examples? What happens if it's like star? What could I like? Okay, if it's LT star. The thing is like, if it has a star in it, then can't I like accidentally do something trippy? Well, this string does the same thing as that. So if there were stars in the actual thing, then there would not be a unique decryption. Okay, so I guess it's just straight up do it. Okay. Actually, it's not that straightforward. Let's think. So you start at this guy, not a star. You go to this guy, it's a 0. You check if there's a number there. And if there's a number there, then you put it in here. Okay. Then you go back, if it's a star, and there's lowercase, uppercase, then you do that. Okay. Okay, so why don't we just do that? And that works perfectly, right? Because every time you find one of these things, it basically decreases the length by 1. Okay, so I is equal to len s minus 1. So that's the end. And then while I is greater than 0, we'll keep going backwards. So if it is a star, or what order do we have to do it? Well, it's either a star or 0, so if it's a star, and the previous one is a lowercase, so si minus 1. However, we have to be careful with negatives. So, and I is greater than 2, greater than 1, and si is less than capital V, less than or equal to capital V, and greater than or equal to capital A, or no, it should be lowercase. And then A is less than or equal to si minus 2, less than or equal to V. Okay. In this case, we gotta swap the previous 2, and then delete the current one. So, temp is equal to si minus 1, si minus 1 is equal to si, and then si minus 1 equals temp. Si equals temp. And then we gotta, whoops, I minus 2, what am I doing? And then we gotta delete the current thing. So literally that's just saying s is equal to s, and then up till I, and then plus s, I plus 1 to the rest. Okay. Okay, and then the other case, if si equals 0, 0 is less than si minus, s0 less than equal to 9, meaning that it is a digit. Dude, there's technically like these Python things for if it's a digit or not, but I don't know how to use those, so it's fine. Then we basically set si to be our s0, And then we just do s is equal to 1 to the end of it of s. Okay. Is that it? Is that all we gotta do? Well then, well, let's think. So, if we delete from the beginning, then do we want to subtract from I or not? We want to subtract 2 from I. So we would do I minus 1 equal 1 here. However, if our thing gets shorter from the end, then we do not want to subtract from I. Oh, we only want to subtract 1 from I because, yeah, so you only want to go back 1. So you would do another I minus equal 1 here. And then you want to return s. And it should be greater than or equal to 0. Okay. Okay, let's try that. Whoops. This got to be a character. Okay. Oh, what? It didn't do anything. God dang it. Wait, what? Alright, why don't we just print s out after each iteration and try again. Okay, so I guess I'm not changing it. Oh, maybe I need to do, okay, maybe this doesn't work. Let's do ord. Basically what ord does is it converts it to an integer. Oh, wait, what? Oh, well, this is a problem, but that should be fine, okay. Yeah, that's the thing. Python does not let you do string assignments, so it would be easier if we made it legitimately a list of chars. So let's see. Convert string Python to list of chars. Okay. Oh wait, yeah, you just do that. Okay. So we could do s equals char for char in it. Alright. Put that up top. Alright. And then where am I adding it from? Oh, and then I should convert it to a string. And to do that, we could literally just do dot join s. Okay. Oh, whoops. This should be the character 0. Hey, it works. Okay, nice. Let us see if that actually is the answer. Oh, we could do that first. Okay, that makes more sense. Broken pipe. What does that even mean? Oh, whoops. Do not want to keep printing stuff out. Let's take that out. Is still a broken pipe? What is the problem there? Time limit? Wait, what? So I can't go through it linearly? Hold up. Oh, this might be, oh, we don't need this anymore. Okay. So for here, we could literally just do s.pop 0. Yeah, if you use the slices, then it basically creates entirely new lists, so that is very inefficient. So this should be a lot better. And then we gotta delete it, so we do s.pop I. Okay. List index out of range. God dang it, how did that even happen? Hold up. Line 28, s0. So I'm assuming it's this, because s0 should always be, and len, and I is less than len s. How did that even happen? Oh, if it goes negative or something? Well, okay, so I is for sure greater than 0 when it goes into this thing, okay. So only this could be the problem. So I guess if it becomes, oh, if it's an empty string, is that the problem? Okay, so it goes -1. Wait, if it's an empty string, then it's fine. So I don't think that's the problem. But if I is not, how could it be out of bounds if it's between 0 and len? List index out of range, is this also a list index? Oh, out of the time limit, how did that even happen? Okay, hold up. So s is between 10 to the 5, so if we always move our I down, I don't see what the problem is, unless it's getting in an infinite loop or something. Wait, how is that even possible though? Hold up. I is greater than or equal to 0, I less than len s. Okay, so if you pop I, that's where you're currently at, and you subtract 1, then that should still be valid, okay. Let's say that you pop your 0, and okay, why don't we make it 0? Let's see. Try making it just a 0 and see what happens. Okay, it didn't bug out. That's not the problem. We got a bunch of zeros? Huh. So what's the problem again? Let's see. Wait, how could it possibly be out of range then? If I is greater than 0, I is less than len s, okay. Oh, does it not recompute len s each time? Huh, maybe we could just do is digit. Let's see if that works. Oh, wait. Okay, that's... Bro, I'm so bad. Why didn't I catch that? Okay, that makes so much more sense. Okay, very small brain move of me. Let us okay, let us clean up the code. Maybe that'll make it go faster. God dang it, dude. God dang it. What am I doing? That should be fine, and that should always be true. Okay, and then if it's equal to that, that's fine. And I is greater than 1. And let's try to fix this. And then we can do the same thing here and do is upper and is lower. Alrighty, let us see. I feel like it's still gonna time out though because I didn't really change much. Okay, so how do we do it faster than just going through each one once? I don't get it. Am I doing any there's only one loop, so that's not the problem, and it goes down by 1 each time, so it's maximum 10 to the 5. Maybe the pops are expensive. Let's see. How can we do this faster? Okay, what we could try to do to optimize this is we could basically initialize an empty array, right? And then just append to it. Answer is equal to that, And then we could just append to our answer. So answer.append, and we could just go in reverse order because we're anyways going in reverse order. So si minus 2, and we want to also append si minus 1 in that order. Okay. And then over here, all we got to do, instead of doing this, we could just do dot append s0. And we don't need this anymore because we're not changing it at all, so that should be fine. And we can do while L is greater than or equal to 0. Okay. And here we want to skip over all the stuff that we already looked at, so that would be I minus equals 2. Oh, so our L should be changing faster. Okay, we should have like a beginning of the list thing. Okay, so instead of this being that, it'll start at 0. And then every time we do one of these boys, we got to do plus equals 1. And then while I is greater than L, then we should be fine. If it's equal to L, let's say that it's only those, then we should still be fine. Okay, so it should be greater than or equal to. And if it's none of the above, then we just want to append as is. So ans.append s0 or si. Okay. And then we want to reverse it at the end, so we'll do reversed. Whoops, sl. Okay, there we go. Is that it? Yes, let's go, finally. Okay, there we go. That took so long. What am I doing? God dang it. Okay. Now find substring. This better be easy, okay? Given a string of lowercase English letters and an integer of the substring length, determine the substring of that length that contains the most vowels. Vowels in the set A, E, I, O, U. Okay. If there is more than one substring with the maximum number of vowels, return the one that starts with the lowest index. Okay. Okay, this seems like a very common problem. Let's see if it actually is. So basically for these kind of problems, whenever you have like a certain length and you're just shifting the window over and seeing like how it changes, you basically add on the first, like the one that you're adding on and subtract one from the other side, right? Like let's say that you have like a bunch of things, right? And your first window is like from here to like there. Then in order to shift your window over, you have to add in this one, right? And then you have to subtract out this one. And basically, we just have to check if this guy was a vowel, we subtract one from our total. And if the guy that we added is a vowel, then we have to add one. So let's just do that. Okay, why don't we do this in a new language, in fact, because this is going to be fun. What's the most obscure language we could do? Why don't we try Go, dude? Go might be fun. Okay. Alright, let's do it. Alright, so is k less than length f? Yes, it is. So all we got to do is do a for loop. So I is equal to 0. I is less than k. I plus plus. God dang it. We can do this. And we'll keep a count of how many vowels we have. So we'll do vowels is equal to 0. Let's see if there's an is vowel in Go. I don't know if there is. What's the best way to do this? Oh, come on. We gotta like manually do it. God dang it. Okay. So essentially what they say to do is to do a switch on the SI. Okay. And then case if it's A, E, I, O, or U. Is it guaranteed lowercase or... Yeah, lowercase. Okay. In that case, all we want to do is we want to increase vowels plus plus, and we should be good. Okay, now we got to keep shifting over this thing until we reach the last possible window, and the number of windows, right? So you can shift it over once if the string is length 5 and your window is length 4, right? Because you have the first 4 and then the last 4. So eventually the number of windows you have is the length of s minus k plus 1. So we got to do for I is equal to in32, 0, and then length s, I is less than len s minus k plus 1, and it's probably going to give me an in32 error, is it? No, we're good. I plus plus, okay, and is it? Yep, god dang it. Okay, but we've already considered the first window, right? So we actually could take out this plus 1, because we already figured out the first window, so we're just shifting it over that many minus 1 times. So switch si again. We can just copy and paste this. So si is the one that we're deleting though. So if we find that it's a vowel, we're getting it out of our list, so we gotta minus it. And we should also keep track of our min string and the number of vowels it has. So min string, or max string actually, is equal to s to k, okay? And then max vowels is equal to vowels after this is done. So we'll do that, okay. Vowels. And then we also got to do the same thing for the thing we're adding, right? So we're subtracting si, which means that we're adding si plus k plus 1, right? No, si plus k, okay. And then we plus plus. And then if it's greater than max vowels, we want to add it to our max string. So if vowels is greater than max vowels, max string is equal to si to I plus k. Or I plus k plus 1 and I plus 1. Okay. And then we just return our max string and we are Gucci gang. Let us test this out. Not found. Oh, we had to do not found? Bro, okay. Are there so many? Are these all not found? Oh, okay, I don't know. We'll see. Okay, so if max vowels equals 0, then we have to return not found. And let us make sure we're reading this right. So, determine the substring of that length that contains the most vowels, okay. A-E-I-O-U, A-E-I-O-U, okay. So basically, what it does is it shifts it over, right? And it starts with the max string, okay. In 32 len f. So it's 5, then it'll go I is less than 0, or I less than 1, which is right. And what does it say if you, okay, the one that starts at the lowest index, okay. Okay, I and I plus k seems wrong. No, that should be right. I plus 1, I plus k plus 1, that is right. Alright, let's try it on a sample input. So why don't we just do like, yeah, okay. So if we make it 5, the best should be 2. Should be the first thing. ASDFA. K, obviously. Oh, wait, it gives you the expected output, so we can put whatever the heck we want. Okay. So why don't we try like, so this one is not calculating right, so why don't we just print out the max string and vowels every time. Or why don't we just print out the vowels at every step of the way. Log.printf. Actually, we should just return. Can we do log.printf? Perhaps we can. Oh, we can do format.printf. That works. And we should do print line. How about that? Wait, what? It got a 4. It got a 4. Then why is it not changing it to that? Okay, why don't we print out I and the vowels? So we could do printf, and we could do like vowels %d, comma, I, %d, vowels, comma, I. God dang it, I should have put a new line, but that's okay. Let us see. So we're for I is equal to 8. So 8 is 0, 1, 2, 3, 4, 5, 6, 7, 8. So it should be that. Why didn't it change the max string though? I don't get it. Oh, I'm so small brain. Oh my god. Okay. So you literally have said vowels is equal to, no, max vowel equals vowel. Okay. Dude, this is like the easiest thing in the book and bruh. Okay. This is why you don't record at 9 o'clock, but it's okay. Alrighty, let's see if it worked. Let us run on all test cases. Easy peasy lemon squeezy. Okay, 45 minutes for a 1.5 hour thing. Not too bad, I suppose. Very good. Alright. Sometimes takes 30 minutes. Okay, sure. While we are waiting, why don't we do some more problem solving things? Actually, do we have to wait? Let's check my email. Okay, why don't we do one more and let's see what languages we can do it in. Let us try some problem solving nonsense. Why don't we do a medium one? I want something slightly complicated. Okay, no, I do not want a magic square. What about climbing the leaderboard? Ah, too long. The problem statement is too long. This is so sad. Okay. You know what? Why don't we just go for an easy one? Why not? Oh, my friend showed me this one. I think this one was interesting. Okay, you will be given 2 arrays of integers and asked to determine all integers that satisfy the following 2 conditions. Okay. The elements of the first array are all factors of integers being considered. Okay. So basically, you're given 2 lists of arrays and you want to find how many numbers are between them. And basically between, it means that it's divisible by all of them in A and it's divisor of everything in B, so that shouldn't be too bad. Let's just try it out. Okay, what can we do with? Let's try Erlang, okay? Okay, I have no idea how to do Erlang, god dang it. What do you guys want me to do in JavaScript? So why don't we just do it in JavaScript? It'll be fun. Okay, so essentially the strategy is so in order to be divisible at everything in A, it got to be the LCM of everything in A, but in order to be a divisor of everything in B, it got to be the GCD. So we got to find the 2. Is there a math.gcd in JavaScript? Let's see. Come on, is there no math.gjs? Come on. Oh, there's no built-in one? Okay, whatever, I guess we could just use Euclidean algorithm. That should be fine. Okay, that's so sad. Alright, function gcd a comma b, and all we gotta do for gcd is return if a mod b is equal to 0, then we return b. Otherwise, we return gcd of b comma a mod b. Okay. And basically, in order for this to work, we had to make sure that A is always greater than B, so let's just be careful with that. Actually, we could just ensure that at the beginning. Alright, so now we got our GCD function, then we gotta find the LCM of everything in B, right? So basically all we gotta do is we gotta keep track of our original LCM, so LCM equals 1, and then A.for each, and then item. We basically want to set LCM is equal to our item times our LCM over our GCD of the 2 numbers. Because basically LCM of A and B is basically the same thing as A times B divided by the GCD, and if we want to accumulate it, we just keep like finding the LCM of the current LCM and the new item. Okay, and then we want to find our GCD, and we'll just assume that B has more than one element, right? We could assume that, please. Oh, what? It can have 0 elements? Okay, whatever. Wait, how is that even possible? If it's equal to 0, then can't it be anything? Yeah, okay, it doesn't really make sense if B has length 0, so I'm just gonna ignore that case. And then we just accumulate our GCD, and we are good. Alright, so now we have our GCD and LCM. We basically need our number that works to be a multiple of the LCM, right? So it's divisible by everything in A, and a divisor of the GCD. So we can literally just go through everything between LCM and GCD and see if it's a divisor. But first off, we need the GCD to be divisible by the LCM. So if GCD mod LCM is not equal to 0, then we want to return 0. Okay. Otherwise, we basically just want to find the number of factors it has, and I'm just gonna do it brute force. We're just gonna go through all the numbers between the two and see if they're like factors. Okay. So we'll start a counter at 0, and then every time we find something that works, so if GCD over LCM mod I equals 0. How do you do integer division in JavaScript? I forgot. There is no integer division. Okay. Then we do counter plus plus. Okay. And we return count. Okay, let's try that. How is GCD not defined? God dang it. I mean, that is confusing. Oh, okay. Maybe I should change the name. Let's see. Why don't we just like capitalize it to be even cooler? Okay, let's see. GCD and then GCD. Try that. When we log out our LCM and GCD right here, 4 and 2. Wait, why is our LCM bigger than our thing? Wait, hold up. Okay, so 2, 4 is our A, so our LCM is that. Okay. Oh, so our LCM is wrong? Hold up. Or GCD is wrong. Okay. Oh, am I using the right array? Oh, dude, god dang it. I was using A. Okay, B dot for each. That makes so much more sense. Okay. Whoops, got to use capitals. Hey, very nice. And let us try submitting it. Maybe this will work. Please work. And it worked! Oh my god, that was crazy stuff. Okay, did I get my email yet? Please tell me I got my email yet. Oh my god, I passed. Now I could showcase that I am a problem solver. This is crazy stuff. Alright, that's all I got for today. I just solved a bunch of problems because some of you guys are asking for Musical Bronze walkthroughs. And honestly, like, Hackerrank is such a good way to prepare for that because Musical Bronze is mostly implementation. So if you practice with Hackerrank, you get so much better. Like, honestly speaking, the only way to get better at coding is just to do it a lot, so hope it helped. Alright, thank you guys so much for watching. If you enjoyed the video, leave a like and subscribe for more. Leave your suggestions down in the comments. I read all of them, so please. But anyways, thank you guys so much for watching again, and see you guys next time.